where?
The center of the circle.
Here. So that is R. So I have a triangle here. The hypotenuse is L. The bottom horizontal bit is R. That's a right triangle. That angle's theta. What is R in terms of things that we know? Or what math relationship will connect these things?
Cosine of theta to R over L.
So R is L cosine theta. So we are now in a position to actually solve for V. So I have 10 times 0.9539 equals V squared times 0.3 over L cosine theta, which is, oh, actually I didn't give a number. Let's make this 0.7 meters. So that'd be 0.7 times the cosine, cosine of theta, which we now know is 0.9539. And so we can solve for V. So it looks like you're just thinking out loud, or is there a question in there?
Wait, how is sine of theta? Oh, wait.
Dominic?
So L, we're just supposed to know that that's given to us?
Yeah, L's given.
Okay.
I'm thinking specifically about a lab that you're going to do where you'll measure L.
And that's just the length of the rope?
It's from the top of
Yeah,
the
from the
tube
top.
to the center of mass 3.
Okay.
You can't really measure R easily because depending on how fast you're spinning, R will
It
change.
changes.
You have an answer?
1.4919.
Units?
Meters per second squared.
Too far.
Per second.
Meters per second. We're finding the speed. Now, given the information that we have here, we have, we're able to solve for theta, what theta should be, and able to solve from there. That's great. Suppose we don't know mass 3. Suppose we don't know the mass of the thing that is swinging around, and that's what we're trying to find using this. We're now in a situation where it becomes a lot more difficult because I can't specifically find theta. So, to deal with that, there's the easy way and the hard way. I'm going to set up the hard way, and then I'll show you the easy way. If there's a big groundswell and you want me to solve it the hard way, I'll be glad to. All right, as it's spinning around, we had ft cosine theta is equal to m, I'll just use little m to represent the swinging mass, mv squared over r, and ft sine theta is equal to m3g, or m just mg. And then ft equals m10g. We can pop that into here. We still don't know what m is, so we have m10g sine theta equals mg. G's cancel out, and we have this relationship m is equal to m10 sine theta. So plugging in that in for tension here and plugging this in for m, we have m10g cosine theta equals m10 tan sine theta, v squared over r. It's a lot trickier to solve this because we have the sine theta and cosine theta, and yes, it's a single variable, but it's a lot trickier to do because that theta is sort of captured inside this function, the cosine and the sine. It's not like you're multiplying cosine times theta, it's cosine of theta. So we need some relationship between cosine and sine. But let's do one other thing. First, we don't know r, but we do know L. So we have, M10 cancels out, which is nice. So we have g cosine theta equals sine theta v squared over L cosine theta. So we have g over L, we have GL cosine squared theta equals sine theta v squared. I know G, I know L, I don't know theta, I don't know V. Also, I got a cosine theta there and a sine theta there, I need to somehow link them. What is the relationship between sine theta and cosine theta?
Divided by cosine theta on each side, you get a tangent on one side.
Oh, sine over cosine? I have cosine squared, so. All right, just to give a look, since I was just going to set up the problem, I know that V is equal to distance over time, so that's 2 pi r over t. R I know is L cosine theta, so that's 2 pi L cosine theta over t. I did not express this, and that's on me, but in theory, if you're doing this, you're timing it, you know how much time it takes. So t is something that you would measure. But we still are left with, because then it's squared. Ooh, is that gonna work out nicer than I was expecting? No, that might. I think we're doing this the back doorway. GL cosine theta, cosine squared theta is equal to sine theta times 4 pi squared L squared cosine squared theta over t. Cosine squares cancel out. One of the L's cancels out. So we actually can solve for theta.
Wait, wouldn't C also be squared?
What's that?
Wouldn't C also be squared?
That L was squared.
No, T.
Oh, T, oh yes, T squared. Thank you. Well, the alternate way, and I have to remember how the problem was worded so that you end up doing another relationship there. What I was looking for earlier is the fact that cosine squared theta plus sine squared theta equals 1. So solve for cosine squared theta, plug into there, you end up with a quadratic. Solving for sine theta, do arcsine, one of the answers will make sense, and then you go from there. However, unless there's a mistake here, this was easier than I was thinking. You're far more likely to show them the test maybe. Then I'll have to wait until ICE Monday for the easier solution.
Can you move back to page 5?
Back to oh.
Thank you. But they sometimes a little hard to see.